that's helps the content.
All right, folks, here we go. This is the actual test review of what's going to be on the test. When you view this, it's going to be right from the test, except for not the exact questions. I'm going to read the instructions to you and give you samples of what's expected, and you are going to hopefully learn how to do them as you go along. So the very first, for the first 4 questions on the test, if you want to take some notes, be a good idea. First 4 questions on the test says this: graph the function and its parent function, then describe the transformation. Graph the function and its parent function, then describe the transformation. Okay, this is what your answer sheet looks like for these. This is numbers 1 through 4, 1, 2, 3, and 4. Just so you can see, it's going to look just like that. And notice that there is a grid and there's a heavy cross in it. That's where your origin has to be to get it right. And then there's a line below it, and that's where you list the transformations. But you're going to put both graphs, the parent and the transformed graph, on here. You following? Okay. So you have to be able to recognize what the parent graph is, because they won't tell you that on this. So the very first one is something like this. The thing that you have to graph is, it says g of x. It doesn't matter what they call it. It's something like negative 1/2 x plus 3. So that's the graph that you have to produce. You also have to produce its parent graph. What is the parent graph for this function? What about x? Yeah, y equals x, or f of x equals x, right? It's linear. It's a linear function. So to accomplish this, as far as the graphing goes, I'm going to have to move this over so that we can see the graph. Maybe I just need to change it a little bit like that. Okay, so hopefully you'll be able to tell what's graphing right there. So first of all, decide what the parent function is for this thing. And then graph them both. The parent function is y equals x, and so you will start at the origin, go up 1 over 1. In other words, split all of these right in half. This is the parent. The blue one is the parent. So determine what the parent is and get it graphed, and then it doesn't have to be in a different color. They can both be in pencil. It's okay, but mine would be mine in different colors. Then graph that thing. Now, you guys all know how to graph this from Algebra 1 and geometry. You'd better know how to graph that. You start at 3, and you drop 1 and run 2. Remember? Start at 3, and you drop 1 and run 2. And you graph that. It doesn't hurt to put several points on there like that. By the way, I will, just so that you know, and once you're done with this, like this, and you graph it down through like that, that's good. That will work. And by the way, you're also like I told you, on your graph, this will be marked with a heavy cross. So make sure that you're using the origin where it's located. Also, so that you can make pretty graphs. If my substitute does not make this available because they forget, this cup of, somebody can reach up here and just grab the whole cup and put it out here where everybody can get it. And use a straight edge so that you can make nice neat graphs if you want. Okay? That's where they are. You're always welcome to a straight edge if you need it. Okay, so the graph looks like this, and then underneath the graph there will be a line. What are you going to put in the line for this particular problem? So on the line you're going to write reflection in the x-axis. You can just write R if you want in x-axis. You have to tell me which axis, and you have to put the word axis. Don't just write x. That's one thing. That's this guy right here. What else? Sorry? Up 3. That's all you have to write. There's one other.
Isn't it a string?
What kind? Vertical or horizontal? Vertical. Vertical shrink of what? 1/2. It's not a steep. Vertical shrink of 1/2. Could you also describe it as a horizontal stretch of 2? You could, but most people don't. But you could, and it would be right. Vertical is what happens to lines. Vertical things happens to lines. Yes. What?
So vertical is right next to the x, and horizontal is when it's on the outside of the parentheses. Horizontal is inside the parentheses.
You can't tell on this one. This could be described as a vertical shrink of or horizontal stretch of 2. Could be described either way, and both would be correct. It's just that when we're dealing with lines, linear things, just lines, we always refer to a shrink or stretch as a vertical one. Since it can be referred to either, we default to vertical, but horizontal would also be correct. Yes.
So if it's like a fraction, it's always going to be a shrink, right?
No. This fractions, if you describe them as a horizontal something or other, fractions end up being the reciprocal of that. Ends up being a horizontal stretch.
So if it was inside the parentheses, then it would be a stretch.
Yeah, that doesn't apply here, not to lines, because it can be described either way. Here's the main thing to look at. It looks like if this thing were as steep as this and standing up straight like this, it's like somebody grabbed these edges right here and either pulled them horizontally, making it flatter, or took those things and vertically shrunk it to make it flatter. We'll usually default to the vertical with a line, but the horizontal, if it's described correctly, will still be correct. It's just not usually done. Okay, that's the first one. Hopefully these won't take as long as this one did, because we'll never get through them all. So, next one is under the very, very same instructions, so we'll clear our graph for a new grid, and the next one looks something like this. Something like this. Number 2 is something like g of x equals -3 times x plus 1 squared minus 4. That's going to be a rough one. What's the parent function? Y equals x squared. Parent function, quadratic. So you should graph the parent, and even if you can't graph that one, you should be able to graph the parent for all of these. To graph the parent for parabolas, to graph the parent function, you start at the origin, you go out 1, up 1, out 1, from there up 3, out 1 up there, from there up 5, get some symmetry points on the other side. And I will expect accurate graphs because I've taught you how to do it quickly and accurately. So here's your parent. Now, how are we going to graph this? To graph a transformed quadratic, you need 3 things. You need to know where it starts. You need to know where its vertex is. You need to know if it will open up or down. And you need to know if it will be fat or skinny. So I would suggest when you show me your work on this problem, besides the graph, that you write this down underneath or somewhere near this problem. Say the vertex is, where is the vertex of this? You can read it from this form. And this is the form that number 2 is in. Vertex of this.
-4.
-1, -4. This goes left, this goes down. Remember? Is it going to open up or down? Why? Why? Because of this guy. Will it be fat or skinny? Skinny, because that's bigger than 1. So we will say that there is a vertical stretch of 3, besides opening down. So this is how we go about it. If you know where to start, which direction to count, and how to count it, you can graph it. So you need to find those 3 things. So we start at -1, -4. And from there, we're going to count down, but instead of going out 1, down 1, we're going to go out 1, down 3. And the next one would be out 1, not down 3, but 9. You won't have that much to count. So just getting these 2 right here will be enough to make it skinny enough to be convincing. Did you understand the 3 count? You normally go out 1, down 1. If this was a 1 right here, it's just a negative, and that's all it was. You go out 1, down 3, out 1, down 5. This one, you go out 1, down 3, out 1, down 9, out 1, down 15. 3 times as far as you would normally go. That's how it stretches it. So there's your graph. Full credit on that, and then there will be a line. Can you describe the transformations? We got one of them right there. Vertical stretch, 3. What else?
Down 4.
Down 4. Left one.
Vertical stretches.
We already got the vertical stretch. Reflect in the x-axis. Now, how would things be different if this were not on this problem?
No reflection.
This would be out of the description and still start here, but you would go out one up 3 and out one up 9, right? And they would overlap a little bit. That's okay, as long as you got them both on there. That's the only difference.
Where did the -1 come from?
Right here.
How did that go?
If adding or subtracting inside before the functioning occurs is a right-left move, the opposite of what you see because it's horizontal. Horizontal things are always opposite. Do you see? Are we clear? Okay, next one. Under the same instructions. Says it has something like this. This one's a lot easier than this one. It looks something, I know I'm putting things up here that are of the same difficulty as what's on the test, but not, for example, that much. How would you graph and describe this one if I had g of x, the function that we want to graph, and its parent, g of x equals, let's say, -x squared plus 4. What is the parent for this? Quadratic. So we graph the quadratic here. Outline out 3 and 5. Symmetries. Parent. We need to know 3 things for a quadratic. Where's the vertex of this one?
0, 4.
0, 4. It's going nowhere right or left, but it's going up 4, right? Up or down? Down. It will open down because of this. Fat or skinny? Normal. That wasn't an option, but that's what you said. Those would be your description of the 3 things. Where does it start? Which direction am I going to count? How am I going to count it?
Why is it normal?
Because this is a 1 right there. It does not vertically stretch or shrink it. So we start at the vertex where we decided, which is 1, 2, 3, 4, and we count down in a normal way. Down 1, out 1, down 3, out 1, down 5. Symmetry points. Describe the transformations. Up 4. There you go. That's all there is on that one. And one more, number 4, looks like something like this. This one's probably the easiest one. Well, it's as easy as the first one. What's the parent function for this? What kind of a thing is the parent function? Pardon me? It's a line, yep. And the parent function for lines goes through the origin and goes into the first quadrant, connecting all the diagonals, and the third quadrant, connecting all the diagonals. There's your parent. What is this thing gonna look like? How are you gonna graph it?
You go up 3 and then
Good. Up 3 and then
2.
down 2 over 1. So it's pretty steep. Well, it's steeper. It's pretty steep. I need to ski down that. Okay, graph's done. Describe the transformations. Up 3. Reflect in the
Wait, how do you tell this?
for lines is always about the x. It's always about vertical things. Reflect in the x-axis got tipped over that negative right there, and then vertical stretch of, there you go. So there's two quadratics and two lines.
So that's what, there's only two quadratics and two lines on the test?
Yep.
Okay.
So there won't be any absolute values and there won't be any constants. The instructions for number 5 say, write a function g whose graph represents the indicated transformations of f. Write a function g whose graph represents the indicated transformation of f. And they're going to give you f and then tell you how to transform it, and you have to write the g that occurs because of that transformation. Okay? Your answer sheet looks like this, remember? These were the first 4, and you have to write their descriptions on these lines that I have, their transformations. This is number 5, so it's going to be an equation. And it's going to say g of x equals. And you're going to take f that's provided and do those transformations to it and write down the result. You understand? So these are all going to be equations. I guess I should have shown you that. 5 starts out with just blanks for equations after the transformation. Okay. So here's an example of number 5. F of x equals, and these are not going to be parent function. These are going to be daughter functions that you're going to transform. And if you do it properly with that intermediate step, it shouldn't be that bad. So I have f of x equals, for example, let's say 2/3 x plus 5. And the transformation you got to do to it, they'll put a semicolon right here like this, and then they will say or tell you what sort of, this one is like this. Translate 4 units up. This is a pretty easy one.
Just add 4 to 5.
Just add 4 to 5, yeah. 2/3 x plus 9 will do it. That's it. But if you were going to apply the thing that I taught you to do on this super easy one, here's what you would say. You would say g of x in an intermediate step is going to be whatever f was in a general way plus 4. So then you take 2/3 x plus 5 plus 4 and get the final result that you put in the answer blank as 2/3 x plus 9. But you can probably tell that this would be the process if it were a harder question. This would be what you would do. You would write down what you're doing to f and then do the algebra to make it happen and get it simplified. Okay, so that was pretty easy. The next one, maybe not so much. This one is going to be quite a bit rougher. This is what you'd write in the blank, by the way. G of x equals. Make sure you're using g because that's what they told you to call it. Okay, this next one is an absolute value function that they're providing for you. F of x equals, let's say, 3 absolute x minus 2 plus 4. And this is what you want to do to it. You want to translate it. No, 5 units right. Right and left, that's vertical or horizontal? Takes place inside or outside?
Inside.
Inside. What you think or opposite? That's all those things, you better get it straight before you start to do this. So, g of x, I'm going to do the intermediate step. This would be a wise one to do the intermediate step because you can really screw this up easy if you try to rush it and get it because it's happening inside, it's opposite, it's weird. So do this intermediate step. G of x equals f of x minus 5. Because it happens inside the function, opposite of what you think. Right is positive, and yet we're going to subtract 5. Do you understand this move? That this represents the translation on f without looking at f yet. So g is going to be, when we actually apply it to f, what that means is what we put inside this function is going to replace this x. So it's going to be 3 absolute x minus 5 minus 2, because that x is being replaced with this junk inside, and then plus 4. Nothing else is changing. Do you understand that move? Then we clean it up inside the absolute. 3 times x minus 7 plus 4. That's what you put in the blank. This is the work that leads to it. I suggest you show me this in case you make an error. Like, for example, if you put plus 2 there, I can forgive the notion that, I'm sorry, if you put plus 5 there, I can forgive the idea that you forgot that it's the opposite of what you think. But the fact that you remembered it happens inside the function, that gets you some points. But I have to be able to see your thinking. So don't try to go from here to here, because if you write just this and I can see no evidence and you miss it all, because I can't tell what you were thinking. So show me your thoughts. Okay, all right, moving on. The only reason I'm going so fast is because on the video you can pause this and look at it for as long as you need to get it understood. So I'm just going to keep hustling through. Okay. Next one. The next one is a graph. And you've seen this before, and I've tried to tell you how to do it. The easiest way to do it. A lot of you still don't listen. So I'm going to put a couple of, the next one is a graph with it not only is a graph, it has a function that you're supposed to transform. But the transformation occurs only in the graph. I'm telling you, don't panic on these. There's an easy way to do this. Let's say we had this function right here. This is the original called f. Like that. And let's say, and so they will write over here on that. They will say this. They will say f of x equals. They will give you the function, which is that blue one. And they will say f of x equals, that would be, notice it's connecting, there's no vertical stretch or shrink, but it is moved over 3 and up 1. So they will tell you the original is the absolute value of x minus 3 plus 1. And they'll ask you to write g, but all they're going to do is give you a picture of g. That's all. They'll just give you a picture of it, you have to write it. You have to write the transformation. So let's say that g was over here, right here, and it was opening like this. Like that. And they're saying, here's the original, here's the new transformed graph, what is g? And what I'm telling you to do is, don't even look at it. Just write this thing's equation. Just forget this. Write this equation, because that's what we're looking for, is an equation for g. And by the way, it'll all be black, it'll all be black and white on your test, so they'll have an F somewhere near this one, and they'll have a G somewhere near this one, so that you can tell which one's which. All you need to do on one like this is write the equation for G. Forget this. Forget this at all. Just write that. So it's going to be the absolute value of, let's look at where it's located now. It's at 1, 2, 3, 4. It's back 4 and up 1. Still opening upwards, but if you count the slope, it's up 2 over 1, vertically stretched by 2. So just write the equation that you see in the graph for G. Forget F when you have a picture. Okay? That's what number 7 is like. Number 8, this is what it looks like, something like this. The function that they give you is not pictured, it's not graphed, so you're not going to have to do that. You're going to have to go back to what we were doing a minute ago. And the function that they give you to transform is f of x equals something like this. 2/3 x minus 3. That thing is what we're going to transform, and this is our transformation. Something like this. Reflect in y-axis. What's the intermediate g? G is going to do what? To reflect it in the y-axis without paying attention to these details. What are you going to do to f, and how are you going to write it? Where? On the x or on the f? On the x. So this is what we intend to do. Y'all agree? So that means in the specifics then, it's going to replace, the x's in f are going to get replaced with negative x. So the intermediate step is going to be 2/3 times negative x, that's just replacing it, minus 3. 2/3 times negative x is negative 2/3 x. And that's what you would write in a simplified version. That would be what you put in the blank. Do y'all follow that? Here we go, moving on. Next one gives you an actual parent function for absolute value is for f. So you actually get a parent this time, not some daughter that you're going to transform. Just a parent, and it's going to be absolute value. I'll even tell you that. F of x equals absolute x.
Your coaches are ready for football players. Go to the gym to have your pictures taken. All football players, please head to the gym. Thank you.
If you're taking off, make sure you take a look at this video. Okay?
Am I gonna be back?
You're likely going to be back. You got 40 minutes. Okay? So if they give you the parent function for absolute, and they will, this is number 9. They'll give you the parent function for absolutes, and this is similar to the transformation. So I'll write it down here so that you can see it. I didn't write the last one, but I'm going to write it. Let's say that they asked you to do a reflection in the x-axis this time. And followed by, so you have this word followed by, so there's going to be several things to do. Followed by a translation five units up. In a general way, how do we do that? I'm going to use H because I want to end up at G. So I'm going to use this intermediate H to do the first transformation. How am I going to do that first transformation to F in a general way? Not specific to the absolute value, but to F in general. So it'll be negative F of X, right? And then to that, whatever that is, and by the way, I'm going to write down what that is specifically. It's just going to be this. That's what H is, our intermediate H, right? Are we clear? To that now, I'm going to move it 5 units up. That's pretty easy. G is going to be H plus 5. You don't need to write this step because it's so easy, but you could. And that would be H, which is negative absolute X, plus 5, and that would be G of X altogether. So here's your intermediate one, which encompasses this. That's your H till we got to here. And then to that, that's what the followed by means. Followed by, to this, we have to translate it 5 units up. And that's what this is, and that's what it is specifically. This is what you would write in the blank. That one wasn't too bad. Take it one transformation at a time now. Are you okay with this? Okay, moving on. Number 10 is another picture, like this one over here. I suggest you figure out what G is and write its equation. That's all. It's an absolute value. Just find G in the graph and write its equation just like we did here without paying any attention to this. When you have pictures, just ignore the F. Can y'all handle that? Number 11 is another one of these. I mean, I got lots of transformations here. If you can do this transformation stuff, you do pretty well on this stuff. If you can, you might not. I don't know. Number 11 gives you a function something like this. It's a daughter function, so it's not a parent anymore. And it is 3x plus 2. Nice line, but it's a daughter line, okay? And this is what you have to do to it. It's some sort of a transformation like this. Horizontal stretch of 4. What should our first intermediate step be? G of X intermediately would be, where's my calculator? Really?
It's like 4 times
Oh.
F, or
F of,
4X.
no.
Oh, 1/4.
1/4 x. This will kill you if you're not paying attention to the fact that it's horizontal. Horizontal happens inside, and if it's a stretch or shrink, it's reciprocal. Think hard about whether it's horizontal or not, and what you're gonna do to it if it is. It's inside and it's 1/4. To make it specific to this problem up here, then G would be what?
1/4 x.
Yep. Good. Great. Here we go. All my siblings. Are you bringing this? Are you bringing that? Are you going to take this? Okay. All right. So here's what we get by plugging 1/4 x in for all the x's in f, and now we clean it up, and what will that be? What's 3 times 1/4? 3/4. Come on, people. A whole number times a fraction goes across the top because that's understood to be 3/1. So it's 3 times 1 over 1 times 4.
Okay.
That should not be a stumbling block at your stage in math. That's what you would put in the blank for that one. But a lot of people remember it's inside, but we'll put a 4. A lot of people think that it's going to be 1/4, but they put it on the outside. You got to get the thing combination right. This makes it occur inside. It also makes this a reciprocal inside.
Well, there's no vertical stretches and straights, right?
Oh, sure. Not in this case, but yeah. In this one, I ask you to horizontally stretch it, which means it's going to take place inside. Okay? Opposite of what you think. Think reciprocal. Okay? That very question is coming up on the next one, what you were just talking about. So here comes the next one. This is number 12. Number 12 is an absolute value function, but it is not the parent. F of x equals, we'll say 2 absolute x minus 3 minus 2. And we want to do a shrink of 1/5. What's the intermediate G applied to F in general?
1/5.
Just like that, right? How do we apply that to the specific G? We would take 1/5 times all of F. It's 1/5 times F, and this whole monster here is F. It applies to all of it. It means it needs to be distributed. So, to clean it up algebraically, what's 1/5 of 2? 2/5. Absolute x minus 3. You cannot get inside that. You have to think of that as a single thing. What's 1/5 of 2? Again? 2/5. It applies to that term as well and needs to be distributed. That's what you write in the blank for this one. That's the final answer because the 1/5 is applied to each one of these terms. This is a bigger term. This is a smaller term. It's 1/5 times this number here, and then this can't be gotten inside, so it just tags along. And then 1/5 times whatever's out here as well. Catch that? Since it was vertical, it was on the outside. And since it was on the outside, it applied to every term. Because it has to be distributed.
Okay.
Okay. All right. Then we move on to the rest of the chapter. Transformations were sections 1 and 2 in this chapter. Now we're going to move on to sections 3 and 4. Do you remember what we did in section 3? That was where you suffered with the calculator and trying to get a line of best fit. So get some instructions written down for yourself that you can follow top to bottom, and you can bring that with you to the test. Number 13, something like this. It says, determine whether the data show a linear relationship. After that, it says, if so. So if you determine that they don't, because when you get them plotted on your calculator, it looks like a shotgun shot it, you would say nope and move on. Leave all the rest of the problem blank. If it does show a linear relationship, when it says if so, write the equation of the line of best fit, and then use it to estimate when X is a particular value. You with me? You understand the instructions? You've seen them 100 times if you did the assignment. Yeah, not 100, but several times. And the data is given something like this. It's in a horizontal format, like this. And it has a describer over here. It says minutes walking. And it even says comma X. So I'll erase this so we can make sure we get it. Words are telling you these are the X values. And this would be distance from home. Something like that, comma Y. And then they'll have some numbers like this. 4, 7, 14, 18, and 28. And then below them it would be something like 1/4, 2.1, 4.3, 5.0, and 7.8, something like that. Okay, they'll have this as a decimal too, so I'll put 0.25. So you would grab your calculator, enter that data in list 1 and list 2. From the stat editor, that's where you go first is stat. So we go stat, edit. If there's something in the lists, you dump them. Put this data in, 4, 7, 14, 18, 28. Oh, dang, I'm supposed to be putting this in list 2. Sorry about that. Let's try that again. I mean in list 1. So I'm going to go clear and come over here to the correct list. 4, 7, 14, 18, 28. And then on list 2, 0.25, 2.1, 4.3. I realize I covered that up for you. 4.3, 5.0 is just 5, and 7.8. And then what do we do next? Build a window. Where do the X's range from?
About 0.25.
These are X's. I would say the first X is 4, so I would say 0 to 35 by 5s. That'll give me 7 tick marks. The others range from 0.25 to 7.8. I'm going to go from 0 to 12. By 1s is fine. Next. What do we do?
No.
Go turn the plot on and erase anything out of y equals. So we go to the y equals screen, clear out anything in the equal sign, turn the plot on if necessary, and hit graph. Do they look linearly related?
Yes.
Yeah, they do. So the answer is yes, so we must continue. What's next? Stat. Go back to stat. Over to calc and down to lin reg. I know you can't see this very well, but I have to show it on the video. And in mine, I have to put in list 1, comma, list 2, comma, vars, y vars, function, y1, execute. Pretty darn good fit. That equation, though, is now in the y equals screen. And when you graph, it appears to fit really well. So you would write, to write the answer to this, you would first of all write the first decision we made, which was yes, it is linearly related. Yes. then you write down this equation, but don't give me all the decimals. It's going to be 0.3x minus 0.36 would be fine. What? You forgot the vars, y vars, function y1 apparently. You can't just skip that. Okay, all right. So then you cut down the decimals. Don't give me all that crap. Cut it down like this. That's the next part, was what's the equation of relation. And then we're going to predict, and I haven't told you what the prediction is, but let's say we wanted to predict how far from home we would be according to this when the 40 minutes has elapsed. So we go to the graph. Watch what's going to happen, because this is a mistake that is likely to happen to you, so pay attention to how you fix it. Listen, if I want to know how far from home I am after 40 minutes of walking, you go second and calc a value, and you type in 40, and watch what happens. You get an error. Why? I'll tell you. Because if you'll remember in the window, you have to go second and quit. If you'll remember in the window, your x's only went to 35. So it will not make a prediction about 40. So what you have to do is come down to your x max and make it something past 40, like 45 instead. So that your x values include the number 40, because that's where you want to make a prediction. Then go back to graph, wait for it to finish, and do it again. So we go calculate a value at 40. Now it'll give you an answer. And the answer is 11.6, whatever it's measured in. I doubt it's miles, but maybe. So at x equals 40, y equals 11.6. This is what I'll be looking for, that number right there.
How do you type the 40 in again?
You have to go to the trace key that says calculate above it. Go second and the trace key and choose value and type 40. Here's what this will look like. Actually, I don't want just the one 11.6 apparently. On your answer sheet, it says for number 13, linear relationship, and it has a yes or no. Circle one. If you circle no, don't write anything else because you're done. If you circle yes, then give me the regression line, right? Y equals. In the REG line, you write y equals 0.3x minus 0.36. That goes here. And then it says prediction and explanation. So in the actual test, this graph will say distance from home in miles, maybe, or something like that. And your explanation would be this. You have to write it out. That's the reason why there's 3 lines. You would say, after 40, that's an R. After 40 minutes, I am, or you are, or whatever, we are, whatever, however you want to write it, 11.6 miles from home. And that's what I mean by the number, and you have to explain it in the context of the problem based on the labels for your data. Okay? The very next problem is like unto it, and I'm not going to do one for you. There's another problem where you have to start from scratch and put information from a table into your calculator, decide if it's a linear fit. If it is, give me the line and make a prediction and explain it. So there's another one just like it. 3 more problems. Are you ready? Last 3 problems come from section 1.4. What'd you do in section 1.4? Elimination and substitution on systems of 3 equations. Yeah, 3 equations. So I will bring the graphing part of this back in a minute, but I got to get rid of it for now.
You did it all day.
So number 14 is very much like number 13 with a different set of data. We'll have to do it twice. Okay. The next problem says this. Solve the system. Then it says, you must show the algebra leading to your answer to receive full credit. Just the correct answer, even if correct, will earn only 1 point.
Did Kylie come in?
First period.
Oh, no.
No. Listen again. The answer to the question, or the instructions for number 15 say, solve the system. You must show the algebra leading to your answer to receive full credit. Just the answer, even if correct, will earn only 1 point. If you have just the answer and it's incorrect, it won't earn any. So here's what number 15 looks like on your answer paper. There's number 15. It says x equals, y equals, z equals. And it says, show your work here. That's what all of this is for.
So there's only
showing your algebra in this box. What?
There's only one problem like that?
Well, you have to show your work, yes. One problem, you have to show your work, but because your work is rather involved, it's worth a few points. Worth quite a bit, so you better be able to show me your work. So just to make this video complete, we're talking about this right here. Number 15, you have to fill in X, Y, and Z, and you have to show how you arrived at it in this box right here. Okay? Do you want to do one like that? You do? So that you don't have to worry, I will guarantee this. This problem will have an answer where there's an X, Y, and Z that are numbers, and those numbers will be whole. They may be negative, but they will be whole. So if you make an error, you can count on that. And it won't be one of those where it's undefined or where you have to write it in terms of a variable or something. He'll have an answer. So here's a sample of it. X plus 4y minus 6z equals -1. 2x minus y plus 2z equals -7. -x plus 2y minus 4z equals -5. I'm going to go through this quickly because I'm running out of time and I got 2 more problems. They can be a bit involved, so I'm going to hurry on this. First thing I notice as I'm looking at my x's is that 2 of them have a coefficient of 1, sort of, and 1 of them has a coefficient of 2. That's an easy thing to use. So I'm going to use x to get the add out first. So I'm going to write down the first equation, x plus 4y minus 6z equals -1. And I'm going, oh, no, that one should have been doubled. Sorry. I'm going to run a -2 through this one. Sorry about that. Let me try that again. Should be -2x minus 8y plus z equals 2. That's running a negative through there. And then the one below it is 2x minus y plus 2z equals -7. And we designed it by running that 2 through, finally doing it right, so that these would add out. So I'm going to get -9y plus 14z equals -5. Do y'all see that? Now I'm going to use these 2, and I'm going to run a +2 through this since I already have the difference in signs built in. So I'm going to run a 2 through this, and I'm going to have these 2 to solve. 2x, that one's not going to change. 2x minus y plus 2z equals -7. And then down below, when I run the 2 through, it'll be -2x minus 4y minus 8z equals -10. Adding those together, the x's add out like I designed. The y's add up to -5. And the z's add up to -6, and the constants add up to -17. So now I'm going to use this equation that has a y and a z in it, and put this equation that has a y and a z up below it. And look at these coefficients and try to figure out a way to get something to add out. That's going to be rough.
10 by 5.
Do you want to multiply, or do you want to try to get the y's or the z's to add out? The y's, okay? Then I'm going to have to multiply this one through by 9 and this one through by -5. so that I can get a negative 45 and a positive 45 for the y's. Do you understand why I chose those numbers? So the new equations become negative 45y minus 54z equals 170, 160, 157. No, 153. Somebody want to check that out on the calculator, make sure we got this right. 9 times 17, is that 153?
Yep.
Okay, so when I run the 5, the negative 5 through here, this time this is a positive 45y minus 70z equals positive 25. How we doing? We okay? Add these together and the y's add out, and I get negative 70 and 54, that's going to be negative 124z equals 13 minus 5 is what? This isn't going to work. I made a mistake here, someone. What?
13 minus 5 is 8.
Oh, this isn't going to work out.
I found the answer.
Well, you have to check. Yeah, that's great. That's great. But just the answer will only get you that 1 point if it's correct. So what does this turn out to be? 128? So somewhere along the line I've made a mistake. And if you're taking a test, you should take the time to go and hunt it down. Yes.
You accidentally made so when you did the 2x minus 4y, you only multiplied it by 2, not negative 2.
Or you scroll down.
Okay, I was trying to multiply. Oh, this right here?
Yeah.
Oh, 2 times.
It's a positive.
Oh, yeah. This is a positive 4. Very good. Nice catch. Okay, so let's see if I can fix it.
On the
The
8.
4 and the negative 1 makes this a positive 3 here. Oh, that's going to make things much happier.
Oh, boy.
So I don't need this anymore because the 3 and the 9 are going to match up beautifully. Thank you for that catch. That was excellent. So I'm going to multiply this one just through by 3 because that'll give me a positive 9 right there. Nice catch on that. Okay, so it'll be 9y minus 18z equals negative 51 over, no, not over, not yet. And then negative 9y plus 14z, because it's not changing, equals negative 5. Close that out. I have negative 18 and 14 is negative 4. Negative 51 and negative 5 is negative 56. And so z is 14.
We have 1 out of 3.
Yeah. If z is 14, then you got to come back in one of these equations up here and figure out what y is. I choose this one because the numbers are a bit smaller. I'm kind of out of space, so I'm going to do it right here. It's going to be really tight. It's going to be 3y. Negative 6 times that 14 is going to be 84. Is that right?
Yep.
Minus 84 equals negative 17. Boy, this is tight up here. Add the 84 to the negative 17. That's going to be 84 minus 17 is 54. Is that right? Oh, really? No. Negative 84 minus 17 is 67. I think it's. It should end in a 3. No. 14 minus 7 is 7. 67, really, is it? Then I made another mistake. Because 3 won't go into that.
Negative 84 minus 17.
Yes. 80, no, not negative 84 minus 17. 84 minus 17.
Yeah.
67?
Minus 17 is 67.
Okay, well, like I said, I made another mistake. 6 won't go, or 3 won't go into 67.
On the calculator, it says that y is 22.3 continuous. So yeah, that's what
23.3?
Yeah.
22.3.
22.3.
I may have written the problem down wrong, but okay, we'll go with this. 20.3 repeated? 22.3 repeated?
Yeah.
Yeah.
And that is what 67 divided by 3 is?
Yes.
Okay, so then you would come back over here and plug it into one of these, maybe this one right here, and we would say x plus 4 times that beast, which will be 88, 89.
89.2.
89 point something, I don't know. But this is going to come out much nicer. Minus 6 times 14, which we decided was 84. No, 50, yeah, 84. And then you will solve for X. But this is the process. This is the kind of work. And you know what? Even though this is really messy and really tight and really ugly, I can follow this. So if you have it this nasty on your paper, as long as you've got things stacked up with lines, and I can figure out where your stuff's coming from. Okay? Now, let's say that you showed the work and you made the same mistakes I did and you couldn't find them. You could. Just continue. If you cannot find the mistake, you can't figure out how to make it right, your calculator's giving you a different answer than you're getting, just continue so I can see that your thought processes are good and I give you most of the credit. Okay? Show your work on that one, though, you get no credit. Well, if the answer's right, you get 1 point out of about 6. Shh. Number 16. Number 16 says, use your calculator to solve the system. And then it says behind it, just the correct answer earns full credit. However, this may have a 3-number answer. It may be no solution. Or it may be infinite solutions and we're going to have to write the values in terms of one variable. But your calculator will tell you. So everybody do this one with me. Everybody do this problem with me and I will show you that situation. If there's no solution, your calculator says no solution, right?
Yes.
If that happens, I would go back and make absolutely certain you put the coefficients in correctly with the correct signs. And if you have, then you write no solution.
So there's 3 unknowns.
Yes.
And 3.
So the answer looks like this, on your paper. Just so that you understand how you're going to answer this thing. Your answer paper looks like this for number 16. It just says R equals S equals T equals. So they're going to be in terms of R, S, and T. Okay there? What are you going to write when, in an answer blank like this when it says R equals S equals T equals if your calculator says no solution? You're going to write no solution hard over all of those. Just write no solution. So that I know that you know that's what you got. Okay? But I would, if I were you, if that happens, go back and make sure that you enter the data correctly with every sign and every number where it belongs.
Do you have 2 more calculators? I've had a couple more kids in my class.
What are you going to do if it gives you 3 numbers? Instead,
So 3 numbers.
solve it on your calculator, you're going to put those in order, right? In that R, S, and T spot. So there's 1.
And I'll have another one come forth now.
Okay.
I'll just come back.
Okay, so put a 77 right there. Okay, good.
Thanks.
Does it work? Do you need batteries?
Well, I've got memories, so we'll see if it all works.
Okay.
Thank you.
You bet. What are you going to do if your calculator gives you something other than that? We're going to do a problem like that so that you understand all the different possibilities. So everybody put this in your calculator. This, I'm going to write the system up here. You put the appropriate coefficients. Negative 2x minus 3y plus z equals negative 6. X plus y minus z equals 5. And 7x plus 8y minus 6z equals 31. See if you can find the solution to that. So just to do this, I'm just going to talk through this so that if you're watching this video, you remember how to handle it. We're going to hold it. Stop. What? Okay, good. We're going to go to apps, alpha 8 to get to polysomalt. Come on, go. Uh-oh. What in the world? I think my calculator finally crashed for good. Oh, man. Can I see somebody else's? That's finally had it. It's gone. It happened in your class. I've had that calculator for a
Alpha 8.
long time. Okay, I'm just going to go ahead and show you the answer because I'm kind of running out of time here. But if you put that in the calculator, the way you know how to put those in the poly simulator, this is the kind of solution that comes out. It is x1 is Can you let me talk for a minute? I know I've been talking all hour, but you have to be quiet while I explain this. Shh. You should have gotten this. X1 equals 9 or plus 2x cubed, or not 2x cubed, it's just 2x3. X squared equals negative 4, not even x squared. X2 equals negative 4 minus x3. And then x3 equals x3. Everything's in terms of z. You must write it that way on your test. So when you have the blanks like this, when it says r equals s equals and t equals, you are going to write this from this information that you see here. You're going to write for r 9 plus 2t. Do you see why that must be?
Yes.
Because x3 is the same as your third variable, and it's t. So be true to the variables. The next one is negative 4 minus t. You can write it like that, or you can write it like this. I would prefer to see it like this. It's a negative 4 and a t. That's what that x3 does. And I don't need you to put the 1 there. That's kind of dumb. And the last one says x3 equals x3, so you will write t equals t. You understand how to interpret the x's with the variables that are in the problem. Oh, mine said x, y, z, so it's going to say this instead. It's going to say x, y, and z if I'm being true to the variables in the system. And then here, this will change to a z. This will change to a z. And so will this. You got to be true to the variables. Do you understand this? You see how they got interpreted this way from this screen? Okay, last problem on the test has to do with mixing together a trail mix with 3 ingredients. So I'm going to read to you kind of what this says, and if I actually write down the system, it's not going to come out because I'm making up the numbers. This will come out nice if you do it right. But it's a story problem, and it says something like this. A local grocery store makes 12-pound mixture of trail mix. That 12 is important. Listen. Shh. The trail mix contains raisins and sunflower seeds and chocolate-covered peanuts. From that, you better come up with some variables like R for raisins, S for seeds, except for S is a very difficult thing to use. It's just like a 5, so you might want to use X, but just make sure you identify which is which. And maybe P for chocolate-covered peanut. The raisins cost $3 a pound. The sunflower seeds cost $1.50 a pound. And the chocolate-covered peanuts cost $3 a pound. No, $2 a pound, we'll say. The mixture calls for 3 times as many raisins as sunflower seeds. The total cost of the mixture is, and I'm going to have to make this up, $23. How much of each ingredient did the store use? You've got to write the system and solve it. And this is what your answer sheet looks like on that. For the very last one, it says, number 17, pounds of sunflower seeds. By the way, that wasn't the first thing listed. So don't just write down your answers in order. Remember which one of the variables, first, second, or third variable represents each of these. Make sure you put the correct amount in each one. Pounds of sunflower seeds, pounds of raisins, pounds of, well, this was chocolate-covered peanuts, this was raisins. You need to write your system here. Then you use your calculator to solve it. You have to write the system here to get part of the points on the problem. You understand?
Like the 3 different equations is the system.
The 3 different equations that you can use your calculator to solve. You need to write the system here. The 3 equations don't have to be in any particular order, but what's going to happen is you're going to have a number one, where the raisins plus the chocolate-covered peanuts plus the sunflower seeds add up to, you're going to poundage. You're not going to count the raisins and the seeds. You're going to measure them by pounds. Remember I said it was a 12-pound mixture? Do you remember that? That's going to be one of your equations. The other one's going to have to do with how much they're worth. So you're going to write 2 times the, or 3 times, I don't know, 3 times the raisins plus 1.5 times the sunflower seeds plus 2 times the peanuts equals the total cost of the bag, which is $23. Understand that? The last one's gonna have to do with the fact that there are 3 times as many ratings as sunflower seeds. So you're gonna have to write R equals 3S. Because you have to triple the sunflower seeds to get the raisins, right?
Yeah.
And then manipulate that so that it all lines up and is equal to 0. Then grab your calculator and make it solve. You understand that? Yes. Okay, that's how it's gonna go. By the way, all the numbers that I read are changed, so make sure you can apply it to these numbers. You know, don't write down what I said, write down what I did. Okay, that's your test. 17 questions, all are required and there are no bonuses. Follow the instructions carefully, get all the points.
So practice tomorrow and test on Friday.
Review, not practice. You'll be doing the actual review assignment called 1.R. And by the way, folks, I cannot assign a review assignment in Big Ideas Math unless I assign all the problems, and I don't like to do that. So all of you are gonna have to do the review on paper, and you have to turn it in completed Thursday before you do the test. So listen carefully to the review assignment. Here it is. Write it down, because you all have to do this one on paper. Write it down.
Wait, this is
I
how
know,
we're
it's
going
double here.
Yeah, it's just getting on my desk.
This is what you will work on tomorrow. You can do it tonight, some if you want. Work on this tomorrow, and then turn it in Thursday before your substitute gives you a test, okay? Follow? All right, here is the assignment. On page 38, numbers 1 through 10. Please add this to the number 10. Predict admissions in year 7. Add that to the problem. Predict admissions in year 7. Add that to number 10, okay? Then on page 20, 10 through 13 and 15. Page 17, 31 and 32.
Wait, what page is that?
17. Page 17, 31 and 32. Then page 27, numbers 14 and 16. And on page 40, do 14 through 16 and 18.
40 through 16.
14 through 16. In other words, 14, 15, and 16, and 18.
On page 27, was it 14 through 16 or just 14 and 16?
14 and 16 on page 27.
What page is it? 10 through 13? 20.
10 through 13 and 15, page 20. Okay, these were handpicked out of the chapter to resemble your test as closely as possible. If you can do these, you'll be able to do them on the test. This is a practice for you. So we assignment to test. Good luck. I'll see you in a week. Please don't trip on or step on my equipment on the way out. I don't have a backup of the programs you need for calculus. It's hammered, it's done. What's the question?
I know, I miss it. I wish
Oh, I forgot to end the stream.
Watch this one.
There we go. What's that?
Do you know